Hi everyone, in this video lesson we will be talking about graphing. Before we go about making a graph, we first have to gather some data. This may come from an experiment or another source of information. For example, I collected this data by looking at the temperature throughout the day. I put these observations in a neatly handwritten table so they are easy to read, but you can also collect your observations in a computer program table like this. As you can see, I included units, and here we are talking about degrees Celsius, so we know what we're talking about, and these are your quantitative observations. There are many ways to represent data, so let's look at a few different types of graphs. The first example is a bar graph, and they're typically used to compare different groups of things, so in this case, pets in the class, but they can also be used to track changes over time. Next, we have scatter plots or line graphs. These both start by plotting points using x and y values, and then you can join the dots, or instead of connecting the points, you can draw a line of best fit, which we will look at on the next few slides. These are the graphs that are most used in science. Finally, our last example is a pie graph, and these are the best for showing parts of a whole at a set point in time. So this pie graph is displaying the favorite social media platforms of grade 9 students. From this, we can see that most of the grade 9s like TikTok the best and Facebook the least. So what makes a good graph? First, the graph should have a title that tells you what it's about. It should also have a legend, because sometimes you can have multiple data sets on the graph, so you need to know what you're looking at. You should also have axis labels, so down here we have a number of absences on the x-axis, and on the y-axis we have grade. Now we should also include units. Here I've just indicated that the grade is a percentage, but if it were temperature, you would want to say that it's degrees Celsius or degrees Fahrenheit. If it was distance, you would want it to say centimeters or meters, and so on. Next, it needs to have a good scale. So as you can see, my x-axis is going up by 2, and it's the same increment each time. Same with the y-axis, we're going up by 10 each time here. Next, on a scatter plot, you need to have a line of best fit that is drawn with a ruler, and you also want to ignore any outliers, and those are points that are far from the rest, and they don't really match the data set. But we'll talk about that again in a few slides. We use scatter plots to see if there's any relationship between the variables. So in this first example, you can see that as the x values increase, the y values are also increasing, and we get this positive upward trend. So we would call this directly or positively related. In the second example, we can see that the x values are increasing, but the y values are decreasing. So we get an inversely or negatively related data set. In this last example, we can see there's not really a clear pattern. So it looks like this variable doesn't have an effect on this one, and we call this no correlation. Next, we are going to look at how to draw a line of best fit. Now this can be roughly determined using an eyeball method and drawing a straight line using a ruler on the scatter plot so that the number of points above and below the line is about equal. And we want to see if the line can pass through as many points as possible. Now I'm going to do my best using the ruler on my iPad to draw a line of best fit. Alright, so I'm just going to eyeball this, and it looks like the data would start somewhere around here. And there you have it. Now before I mentioned outliers, and an outlier would be if you had a point that were somewhere down here. It just didn't match. In this case, you would ignore that because you wouldn't want to skew your line of best fit. That concludes this video lesson. If you have any questions, don't be afraid to reach out.